Hi everyone, and thanks for joining Understanding AWS Storage Options. My name is Guy Farber. I'm a business development manager with Amazon Web Services focusing on storage. And what drew me into the data storage industry is the fact that data keeps growing and always presents an interesting challenge. And my goal today is to show you how you can leverage cloud storage services, AWS cloud storage, in order to accommodate and better deal with the explosion of data. So we're going to talk about several storage services today. The reason why we have multiple services is because data and applications, they come in different shapes and sizes. They have different performance and cost requirements. They have different data access interface requirements. And so we're going to first talk about scalable object storage. This is optimal, an optimal approach for storing a large number of files, anything from office documents to movies, audio, and photos. Then we're going to quickly discuss how to best manage and store infrequently accessed data sets. This is where we're going to talk about inexpensive archive storage. We'll show how you can get persistent, high-performance block storage for AWS's compute service, EC2. And then finally, we are going to talk about a service that allows you to easily ingest or transfer data from your on-premises data center into AWS storage services such as S3 and Glacier. And then finally, we're going to have Ilana Rabinovich from Wally talk about some of the storage use cases they have within their operation for S3 and for Glacier, as well as some best practices and tips. We as consumers now carry multiple mobile devices, and we continuously capture moments and memories in the form of photos and movies. And we expect to be able to go back and review those even several years back and to be able to share those with friends and families. And this constant creation of content is creating an enormous amount of both volume and velocity of storage that traditional storage subsystems were not designed to accommodate. And it's not just consumers that are generating all this data. It's also industries that are now finding new ways of leveraging data storage and processing to enable new businesses. Anything from the financial services industry, where they will do massive risk simulations and fraud detection, to the media entertainment industry, which now allows us to view movies at 4K quality at home, which sometimes take as much as terabytes to store, up to the oil and gas industry, my beautiful and romantic oil rig in the sunset image over here, where AWS customers such as Shell now collect data from sensors undersea all the way down to the tip of the drills and then upload it to S3 for further processing. The best platform to address the massive growth and the need for scalability for file data is object storage. So for those of you who are not familiar with object storage, what it is it shares some similarities to a file system, but instead of having a directory or a folder structure, we store the files in a completely flat namespace. And instead of relying on the file system to store the metadata, we store it with the objects, with the files, and then they're called objects. So a file that has an associated set of metadata is then called an object. And what that buys us is tremendous scalability. It gets us ease of management because we don't need to manage data in volumes. Instead of that, we just manage one large flat namespace, and it's a lot more durable. And I'll discuss these things further. Amazon's managed or cloud-based content storage offering is called S3. It stands for Simple Storage Service. And some experienced storage admins might say that's an oxymoron, but really it has a really simple interface where I can access through an API over HTTP, and all I need to do is put objects and get objects. Everything else is automatically handled by the service. I don't need to do capacity planning. I don't need to worry about performance. I don't need to worry about data protection. All of this stuff is handled automatically by the platform. It's also the first service that we launched. We launched it more than 8 years ago. So it's very mature. It's very well adopted. And we have large customers such as Dropbox use us for content collaboration, both for consumers and for businesses. We have Netflix use it as their origin store for their movie streaming service. And then Pinterest is using it for their pins to store the photos, as well as the massive amount of logs that they process as part of their big data analysis. And these customers don't just love S3 because it's simple to manage and it offloads them from having to manage storage. It's also because of the scalability, that they know that no matter how much additional business they're going to gain because they release new features or they release new promotions, they're going to have as much capacity as they possibly need. And just an anecdote, S3 has been storing for years trillions of objects, and for those of you who attended Andy Jassi's keynote today, we released a new metric mentioning that the year-over-year growth in overall data transfer in and out of S3 has been 137%. So the service is still growing massively. But it's not just great to allow you not to worry about capacity, providing you unlimited capacity. It also addresses the issues around performance. So when you size up a traditional storage system for performance, you need to think about, you need to forecast or predict what is going to be your peak performance requirement. With S3, the more requests you throw at the service, the more performance it'll give you. It scales fairly linearly if you follow some very basic best practices. So that's another thing you don't need to worry about is performance. And then it's also very durable. And by durable, we mean the ability to protect the integrity of your data. The statistical measure of S3's durability is 11 nines. And the way we achieve that tremendous number is the moment you put an object into S3, we'll automatically replicate it across multiple fault-isolated facilities within the same region. If we can handle a full facility failure, so we can recover from a full data center failure and additional device failures in the other facilities concurrently while still serving your data. And when we need to do the recovery, when we need to recover the data into the facilities that are then being brought up, we do that automatically behind the scenes. So this is a completely automatic and seamless disaster recovery enabled service. And then we have customers that are saying, you know, we understand that S3 pricing is very compelling, and we're going to talk about that in a few minutes. But, and it's great that you have 11 nines of durability, but we do have data sets that are reproducible or are very temporary in nature, and we can settle for less durability, and we'd like to pay less. And so we introduced reduced redundancy option. What that gives you is 20% roughly on average discount on our public pricing, and you only get 4 nines of durability. Still a lot better than most clustered systems, but not as good as the 11 nines of S3 standard. And it's very easy for you to transition an object from standard to reduced redundancy. It's basically just a property of the object. So if you change your mind, it's still very easy to make the adjustment. Going back to the simplicity of the model, how it actually all looks. So the first thing you need to do when you want to provision petabytes of storage within minutes is choose a region. Where is the data going to be located? The service is available through 11 regions after we introduced Frankfurt, Germany last month. Once you choose a region, you create a virtual container called a bucket. And a bucket is unlimited in capacity, and you can store as many objects as you wish in the bucket. What it allows you to do is gain some separation from an administrative standpoint. Say, for example, you have multiple business units within the same organization, and you want to do chargebacks separately for each bucket. This is where you'd use buckets, for example, or for security purposes, some security separation. Within those buckets, we store objects. So this is pretty much all I need in order to start streaming movies serving photos and so forth as a storage service. But it's also a web service. So I can actually access, given the right permissions and security credentials, I can directly access these objects by accessing bucketname.amazonaws.com/the object name. And what that allows us to do, and I think Ilana is going to give us a more detailed example in his presentation, is we can directly offload all the static content serving away from web servers directly into S3. And you don't have to use the S3 endpoint. You can put your own DNS name in front of it, and of course, optimize the delivery with a content delivery network such as Amazon CloudFront. So all you need to do is basically set up your bucket, put some objects, and then you can serve static content directly from S3, not having to worry about load balancing, having enough compute capacity, and so forth for the static part of your web serving. So then you may ask me, oh, you got all these great benefits, but how do I compare the cost of this service? How does it stack up against what I'm paying today in my data center for traditional storage? So one of the key things you need to keep in mind is that traditional storage comes in raw format, which means how many disks do I have in the system multiplied by what's the size of the disks. The product of that is the overall raw capacity of the storage. Unfortunately, you can't really use all that capacity. You need to first of all apply some measure of data protection, such as RAID or erasure coding or something like that, and that takes some overhead. In my conservative example, it's 20% and I'm left with 800 terabytes. Then I need to put a file system on top, maybe some additional storage related features that create additional overhead. And now I have 600 terabytes. But as any experienced storage admin knows, I can't actually use it to capacity. I have to have some spare capacity, and I'm managing many of these volumes. So I have to leave some room for an operational reserve to make sure I never run out of capacity, I never experience downtime. Comparatively, with S3, even though we apply a very high measure of data protection with 11 nines of durability, after applying that data protection, we only charge you for what you actually use, and when you use it. So for example, here we have 400 terabytes. We'll only charge you for 400 terabytes. And the way we charge you is on a measure of gigabytes per month. So here's how it looks like. This is a picture, a photo of our public website. And in our core regions, customers pay 3 cents per gig per month for the first terabyte. And as they use more capacity, they gradually pay less. It's a tiered pricing structure all the way down to 2.75 cents. So this is pretty inexpensive for just net usable data. But what you also need to take into account, usually when you forecast expenditures for storage systems, you look 3 to 5 years ahead, is that our pricing is not static. We have a very strong history of price reductions. Ever since we launched the service 8 years ago, we actually cut our pricing a total of 8 times. And the most recent one, in April of this year, we cut it 51% on average. This is pretty significant. And as you factor in some measure of price reductions into your model, that significantly changes the way our TCO looks like on a 3 to 5 year basis. Which then brings me on the topic of TCO, how do you look at your own costs, at the cost of hardware-based storage? Make sure you take into account the cost of the hardware, the software, the maintenance, the associated data center costs, power and cooling, the administrative overhead required to manage the systems, and the cost of capital tied into the upfront procurement of those systems. We know it's pretty complicated, and I've been involved in quite a few of these modeling exercises. They tend to get pretty involved, so I like to offer some help. We have an expert team of TCO analysts that can help you out. If you need assistance, please send me an email or just contact your AWS account manager. We'll be glad to help and help you with this exercise. A great example of a customer that's using S3 to focus on the development of their service, of their application, instead of the undifferentiated heavy lifting of managing storage is Yelp. Yelp allows you to rate and to search for local businesses. I'm sure most of you are aware of their service and are using it. This is where you get stuck on a weekend with your toilet broken and you try to figure out who's the best rated plumber out there, or you want to find the best ramen 4 blocks away. The way they do it is they analyze a lot of log data, and they store that log data in S3, and they use that to power things like autocomplete as you type, review highlights, and figure out how to place their ads. In addition to relying on S3 for this log storage, they also put all the photos that are generated by the users on S3. So just to summarize S3, where do you use object storage, AWS object storage, and specifically S3? You want to use it when you want to focus on developing or managing your application, not having to worry about capacity or performance, and just benefit from the web scale nature of S3, regardless of what types of performance and capacity peaks you may experience. You need this when you need to have high durability, 11 nines of durability that we provide. It's also a great platform for backup and archive. It was really optimized for write once, read many, so backup and archive, a great use case. And then finally, as a single origin for when you want to stream things like movie and audio, and optimize the delivery with a CDN such as Amazon CloudFront. So then customers told us, S3 is great, we love the durability, we love the simplicity, we have data sets that we very infrequently access. These are the deep archive type of things, and where we need to keep them around for future reference or for compliance purposes. So that's where we introduced Glacier. What's great about Glacier is it costs 1 cent per gig per month. So if you do some quick math, it's almost a third the cost of S3 in our core regions. That's great, right? Lower cost is always good. Some customers are telling me, I can't figure out this gigabyte per month thing. I need this in terabytes. So I came prepared with a calculation. It's $120 per terabyte. If you want to project it over 3 to 5 years, you see this is not going to be too difficult. And it's got the same durability model as S3. So you know your data's integrity is going to be intact. And sorry, I'm going to go back and say one more thing. Compare this to tape, because the majority of people, of customers, archive and do long-term backups into tape. Tape's durability is not great. We all know it's awesome for backup. It's just not so great for restore. And we've all been in this situation. So part of the value proposition that Glacier brings you is that it's got that very high level of durability. So what are you trading off in terms as customers? You trade off the RTO, the recovery time objective. Glacier has a somewhat similar paradigm to tape vaulting. When you need to retrieve files that you lost from a tape vaulting provider, you need to call them up, and they need to send you back tape media, and it might take a few days. Here, you need to wait 3 to 5 hours. So from the moment you request an object to the point when it's available, your RTO, 3 to 5 hours. So as you look at figuring out what to put on S3 and what to put on Glacier, take the retrieval time into account, and take into account one more thing. Because Glacier was designed as a deep archive service to enforce the correct behavior and to support our cost model, we also apply a retrieval fee above the free tier of 5% of your overall capacity monthly. So for example, if you have 100 terabytes in Glacier and you try to retrieve more than 5 terabytes, that incremental amount, we will charge you retrieval fees. So if you have frequent retrievals, this is probably not the right service. S3 is better suited for that. But if you have data that just sits around and you don't touch it, then it's great for Glacier. That's the positioning. So where do we use Glacier? Again, it's great for long-term archiving, long-term backup, especially in these sort of situations. We keep adding data. We normally don't delete much, so it keeps growing. We want to benefit from unlimited capacity. It's a great opportunity to completely get rid of tape museums, right? This is where you keep multiple generations of tape libraries, because LTO only supports 2 generations back, and you have to keep refreshing them or rehydrate the data. We can solve all of these problems by just transitioning to Glacier. and also enjoy much better durability in the process. But it gets better because S3 is actually integrated really well with Glacier, and I have the ability by policy of transitioning objects from one to the other. And here's how it works. So even though S3 is an object store, it allows you to represent directories as virtual directories. The way you do it is you create a prefix, and in my example here it's logs, and then you put a delimiter after that, like a /. So this makes logs look like a virtual directory. And what I'm going to do here is I apply a policy that after 30 days, take all the objects that start with logs or are in the logs virtual directory and then transition them. They're at that point less valuable to me, but I still want to keep them around for future reference. Maybe I want to run a new algorithm in the future on these logs or something like that. I keep them in Glacier, and from that moment, effectively, I'm paying a third the cost. So I'm enjoying the cost reduction. But it's also good to automatically delete objects. A lot of people are running into this situation where someone put a bunch of logs or some other types of files in an S3 bucket and they just forget about them. At some point, there's no value to the data, and it needs to be deleted, but it just sits there accumulating cost. This is a way for you to automatically control it. Here in this example, after a year, all the objects that are a year old in the logs virtual directory will get deleted. A great example of a customer that's been leveraging this functionality is SoundCloud. They're the world's leading social sound platform. What they do is they're based in Germany. They allow artists to upload their music and their sounds, and then they deliver it on their behalf to different mobile device platforms and social media, and allow them to promote their art and to distribute their content. And SoundCloud stores more than 2.5 petabytes on S3 and Glacier today. And the interesting thing about how they use it is, as they receive a new piece of content from an artist, they will automatically transcode it to the multiple formats required for delivery and deliver it in real time out of S3. But they'll also keep the original in Glacier, thereby significantly reducing the cost of their long-term storage, because they want to keep all these originals for the long term for their users. So just to summarize, lifecycle policies are great to tier data in the cloud. They have another very powerful use case with S3 versioning. S3 versioning allows you to keep multiple versions of the same object. So if you accidentally delete an object or experience data corruption, you can go back to all these previous versions or recovery points. What lifecycle policies do for versioning is, one, it allows you to limit the number of versions that you keep by putting in a deletion or expiry policy after a week or a month. Secondly, it allows you to move those versions into Glacier, making that data protection mechanism a lot cheaper, a third the cost, effectively. So far we've been talking about storage for files or for objects. What about my transactional, applications that require block storage? So with block storage, we have a few services that to the host, to the compute instance, look exactly the same way as a SAN volume looks like in the traditional world. We have two types of options here. The first one is called instance storage. This is just storage that's included as part of the EC2, the compute instance. And it's great, it's simple, and it's included. The disadvantages of instance storage are two. One, it's tied to the instance. It's not persistent. So the moment you terminate the instance, it goes away. If you need persistency, this is not going to work. Secondly, it doesn't provide the same level of performance and some of the advanced functionality that we have with Amazon EBS. So EBS is the other option, elastic block storage. And the difference here is that this is a network-based service. It's not tied to a specific instance. I can map it to different instances. EBS allows you to create volumes that are anywhere from a gig in size to 1 terabyte. Once you create a volume, you can very quickly attach it to an instance. You don't need to provision any networking or fiber channel or any of this usual stuff. You just map it into the instance. The moment that volume is ready, you can start reading and writing from it, and it'll also automatically, synchronously mirror itself to another volume in the same availability zone. If you need additional protection beyond that, we recommend that you replicate the whole instance into a separate availability zone if you want to be able to recover from a full data center failure. But by default, we will make another copy for you automatically. If you ever need to take benefit of a new instance that we just released that provides better price-performance ratio, all you need to do is quiesce your application, unmount the volume, and remount the volume into the new instance. There's no need for data migration, and this process is very easy to automate in case you need to do it across hundreds of thousands of servers. And you can also attach multiple volumes to the same instance. Reasons why you may want to do this: you may want to run a host-based logical volume manager to stripe multiple volumes, which will allow you to overcome the 1 terabyte limit of an EBS volume and create larger volumes. Or maybe because you want to aggregate the performance of multiple volumes because you hit the limit of whatever performance we allow per volume, which I'm going to discuss in a minute. And then finally, to gain performance isolation between applications or application components. For example, with an Oracle database, maybe I want to put the database files in one volume, and I want to put the logs in a different volume. Same as I do in a traditional SAN, I can do that over here as well. Which then brings me into the different volume types. This service has been around for a while, and so it evolved a little bit, and we have three types that we offer today. The simplest one is called magnetic. This is, for those of you who are familiar with EBS, it used to be called EBS standard. It relies on magnetic disks. And so the performance is not very deterministic, and it's not very high. It's on the order of 100 IOPS per second per volume pretty consistently, and then you can burst for a few seconds above that. It's fairly inexpensive, and it's really today positioned only for infrequent data access use cases. On the opposite side of the spectrum, for very demanding, intense transactional workloads where I need to absolutely control the number of IOPS and the latency that I'm going to get from the volume, we have provisioned IOPS. With provisioned IOPS is based on SSD, on flash drives. It allows you to dial up the level of performance that you want. You can basically specify how many IOPS you want, all the way to 4,000 per volume. And then don't forget that you can aggregate multiple volumes together to get even higher levels of performance. But provisioned IOPS is a little bit more expensive, and it's a little bit less predictable in terms of cost. Why? Because there's not just a fee of 12.5 cents per gig per month for the actual storage, we also charge you for the number of IOPS that you provision. But in June of this year, we introduced a new volume type that strikes a really good balance between the two. And it's called general purpose. It's also based on SSD, and it was really designed for boot volumes, small to medium databases, and test and dev environments. But a lot of customers find out that this is actually great for all of their use cases. So what this allows you to do, it uses a little bit of a different model where you get 3 IOPS per gig, all the way to 3,000 IOPS for a full volume. We allow you a certain measure of burst, even beyond 3 IOPS per gig. So even if you have a little bit of bursts in your application, we can accommodate that. But it's also very inexpensive and predictable in terms of the spend. You only pay for capacity, and it's 10 cents per gig per month. And because it has such great TCO, we made that the default volume. So when you create a volume today, it'll be, not provision IOPS, general purpose, as the name implies. One of the most powerful EBS features is snapshots. What snapshots allow you to do is to take a EBS volume and start creating point-in-time recovery snapshots. And as soon as you create the first snapshot, we take a full copy of your volume, we compress it, and we move it over to S3 that we've already established is very durable. So that's a good place to put these snapshots. Subsequent snapshots, we're only going to take the incremental amount of data that's generated, compress it again, and again, put it for safekeeping in S3. And what that allows me to do is if I accidentally have, the human factor, delete some files from a volume, or I encounter data corruption, I can go back to each one of these recovery points and restore my files. In addition, this is also a great way to move data around for data mobility, because I can take these snapshots, I can copy them to a different availability zone or even a different AWS region and create a volume from that snapshot as a baseline. So I can use this for anything from a very high RTO, RPO disaster recovery by actually doing copies between regions to just a quick way of cloning test and dev environments, BI environments based on real data that's in this original volumes. So where do we use EBS? Why do we use EBS? We use it when we need persistent block storage for EC2. That's absolutely required. For transactional workloads that need a high level of performance. When we need when we have very intense levels of performance, we tend to recommend provisioned IOPS, because this is where I can really specify exactly how much IOPS I'm going to get. It's very deterministic. And then finally, if I need to create a file server within the EC2 network available to the EC2 instances, I can simply utilize logical volume management and RAID, and then put a file system, any Windows or Linux file system on top of that, utilize that as a file server. So far we've discussed cloud-based storage for files or for objects, and dedicated block storage for EC2. But you may ask yourself, this is great, all this object storage that's API access, it's great for developers. They can tightly integrate storage into their applications and really customize their access. But what about IT organizations? They use a different set of interfaces, such as iSCSI, for example. How do I take my data that's currently sitting on my existing data center and move it into the cloud? How do I do things like backup and archive? So here's where the AWS Storage Gateway can help you. I'm not going to have a lot of time to talk about this today, but if any of you are interested, Brad Karlstad is going to be taking a deep dive into backup and archive in the cloud at 4:30 today, and you have the details of the session at the bottom. So the way the Storage Gateway works is it basically gives you an on-ramp or an endpoint inside your data center that allows you to upload data to S3 and to Glacier. You go on our website, you download a virtual machine, you can have a 60-day free trial to test this out, and you drop it into an ESX server or into a Microsoft Hyper-V server. The virtual machine utilizes local disks for buffering and for caching, and it presents a local block level or VTL iSCSI interface. So you can basically take your existing backup application or archive application, point it at the iSCSI interface, and start copying, backing up, or archiving files. These files are then going to be cached and buffered, compressed, encrypted, and sent over to S3 and Glacier for persistent storage, enjoying the, benefiting from the high level of durability. So to summarize, before I hand this over to Ilana, AWS storage is all about choice. You have multiple services to choose from for different types of performance, cost, and interface requirements. You can use all of them in combination or just one of them. You only pay for what you use, and you can use this to do a wholesale migration of your storage to the cloud, or you can just use it to augment what you currently have and instead of growing inside your data center. I'm going to be available for questions after the session, and with this, I'm going to hand this over to Ilana, who has a very interesting presentation on how they use S3 and Glacier. Thank you very much.
There we go. Hi, everybody. Thanks, Guy, for the opportunity to speak here today. So as Guy mentioned, I'm with Wally. My name is Ilana. I'm the engineering manager for the infrastructure and reliability team. What that means is that I get to play with lots of cool cloud technologies like some of the AWS storage stuff that we're talking about today, and help our various engineering teams be successful as they operate in the cloud. So we'll just talk a little bit quickly about the history of Uyala and our time with AWS. So we were born in the cloud back in 2007. From the start, we've been running on EC2 and S3, and our co-founders got together around that same time and won the first AWS Startup Challenge, putting together a compelling video delivery, monetization, and analytics platform, again, using EC2 and S3. So what is it that we do? Our mission is to help our customers bring personalized video to every screen everywhere. So if you're watching TV, if you're watching video on your phone, on your tablet, your TV, your computer, anything in between there, it's likely at some point you've come across Uyala, you just don't know it. I like to say that if I'm doing my job right, you shouldn't. We're helping our publishers get their brand out there. So we've continued to sort of grow in our use of AWS since then. As AWS has had more offerings, we've kind of jumped to them as well, really loving our time in the cloud here. So today we use things like EC2 and S3. We're kind of jumping right now into the VPC, into the new VPC networks. We're working with things like CloudFront for API acceleration as well as file delivery, and using things like Direct Connect to get a good, fast and cost-effective pipe into Amazon Web Services. So let's dive into some storage use cases because that's what you're really here for. So you might think the first thing I talk to you about as a video delivery platform is video, but no, let's start actually out with some of our log storage use cases. I mentioned earlier that our goal is to provide a personalized video experience on every screen everywhere. In order to do that, we have to be a very data-focused company. We have this voracious appetite for data. We log everything. We get telemetry data from our player about everything about your video delivery experience. We're collecting data about our publisher's API usage. We're using that to do things like recommend that next cat video that we really think you'll like to watch, or help our publishers understand how you're consuming video and what videos to show you next. So give them these deep insights into their content and into their customer base. In order to do that, we have to collect all this data, and so we're collecting billions of log files, and we're having to store them somewhere. And what better place than S3, right? It's very easy. Logs and telemetry data come into our EC2 instances. We have fast and reliable storage from there, uploaded to S3 just with a simple put. Later on down the pipeline, we're able to get it back down using Hadoop and Spark in our data centers to do that, to generate those analytics insights and recommendations. So kind of see what that looks like here. Data comes in through the cloud through EC2, gets logged into the bucket. Our corporate colos, where we're running Hadoop and Spark, get to that through Direct Connect for really low latency connectivity. And then we're using those lifecycle policies that Guy mentioned for long-term data. We're really data pack rats. We don't like to throw any of that away. We might want it someday. Almost never do, but someday we might. And we'll talk about that a little bit in a second here. And so that's where those lifecycle policies come in. They help us keep our storage costs sort of at a reasonable level. So what are some of the lessons we've learned here? S3 is awesome. You get infinitely scalable storage. You're never off buying another shelf for your storage array. You're not buying more disks for your SAN, whatever it might be. It's just you upload data, and they deal with it no matter how big and how small. The automatic archival of data using Glacier is great as well. Don't have to put a lot of thought into it. You can set some policies. 30, 60, 90 days, a year, whatever it might be. You can move to Glacier and eventually expire it, again, keeping your cost low. If you're doing a lot of work with S3, backwards and forwards from like your MapReduce workloads or whatever it might be in your data center, Direct Connect is also a great way to keep those bandwidth costs low, as well as keep performance high. So some general tips. Know your access patterns. Like I mentioned, if you're looking to access your data pretty regularly, Glacier is probably not a good fit for you. We moved all of our log data into Glacier when it first came out. We're like, awesome, we've saved a ton of money. And then about 6 months ago, we said, you know what, we need all of that data back, and we need it right now. Because we wanted to reprocess it, we wanted to distill some more data out of it. Turns out that's a very expensive endeavor. It worked for our use case. You just have to think about it. Like, had we planned ahead a little bit more, we might have been able to avoid some of that. The other thing to keep in mind is if you're using S3 import-export a lot, you have to thaw your data out of Glacier there and get it into S3 first. So again, you need to do a little bit of planning ahead, make sure that you're planning, that you know what you want to get out. And then finally, security. The data that you're building is probably one of the most valuable things that you're collecting is probably one of the most valuable things that your company owns. You want to keep that secure. So use things like IAM keys and instance roles to help lock down the specific areas that you're offering access to, and rotate those keys regularly, sort of like what Andy was talking about today during the keynote. Keep an eye on security there. So yeah, video. We were talking about video a little earlier, a video delivery platform. And again, here we're pack rats. We just don't throw any data away. And after many years of storing data in S3, we realized we're keeping around a lot of video for that maybe our customers have deleted, maybe we don't need any more other assets at Uyala. And so we realized that there are over 200 million assets that we could just, of these large video files, that we could just delete from S3 and reduce our costs significantly. We wanted to use the cloud the way you're supposed to. You use it for what you need and not for what you don't. So that's the benefit of we get in the pricing there. So we built the service called Wally. This is an internal API at Uyala that our various other services can talk to and say they'll flag an asset as being something that's ready for deletion. Wally will wake up, look at that job queue and say, awesome, I've got all this data to clean out of the S3 junkyard. I'm going to take it over into a trash bucket. It moves those assets over using a bunch of spot instances, copies that data over into a trash bucket where we set a 30, 60-day lifecycle policy. If nobody complains that that data is now missing, it's gone. We've now done some spring cleaning, saved a ton of money, and helped keep costs down for ourselves and for our customers. So there's a little diagram there about sort of how that workflow works, and there's a great post on our engineering blog. I'll share a link later with sort of the details of that workflow. So some tips. S3 is deceptively easy to use, which is great. Like, you end up storing all of these things that you forget about. It's like your attic or your storage unit at like U-Haul. You put stuff in there. Years later, you show up, you're like, I really didn't need that. Why have I been paying this much to keep it around for so long? So automate your data retention and deletion, because you're never going to have time to think about it. Safety first. So use S3 versioning or a temporary storage location to move stuff into when you're deleting things, so that you can think about it, so that if it does disappear and you do need it, you have a way to restore it quickly. And then finally, spot instances are just a fantastic way to run workloads in EC2 at a low cost. So encourage you to look at those as well. Cool. So the last use case I'll touch on is client-side web applications. Over the years, we've built a number of web applications that our customers use. Things like CMSs for managing their video content, or templating services to make a prettier video player, things of that nature. And so some of what we do there is, what we've done over time is we've taken these very thick web applications where maybe the front end part is part of the same application as the back end. We've split them up into a very service-oriented architecture. So you have rich client-side JavaScript-based applications that are interacting with back-end APIs where the data is actually stored, and you're able to provide a very rich and dynamic experience for the users, very performant, as well as being agile for your team, so that the various teams that are building web applications can compose those APIs into different things. So we're starting to build some of these web applications, and we realized, why run an Nginx or an Apache server? That seems like it's not a lot of work. We all know how to do it. It's something that we learned how to do in the 90s as part of the first web bubble. But why bother? We have S3. It does it for us. It scales automatically. It's secure. It's easy to use. What's easier than just putting a file to the bucket? So enter S3 websites in CloudFront. What we've done there is we've taken a number of our applications and basically just upload HTML, JavaScript, some images into S3. We've dropped CloudFront in front of that to accelerate it and cache it so that it's available in all the regions around the world. And now our web development teams are not worrying about Apache configurations or deploying files to EC2 instances. They just upload them to S3. Very straightforward process. And then, of course, as I mentioned, AJAX-type interactions with server-side APIs and data. So things to keep in mind there. Again, it's very easy and repeatable deployments. There's nothing easier than uploading a file to S3. There's 100 tools to do it. Very, very straightforward. It scales easily and securely. There's no web servers to manage. You're not worrying about the latest heart lead bug or whatever it might be. Amazon just sort of handles all of that for you, which is fantastic. And then it's very low cost to deliver. I mean, the storage is, you're not storing terabytes of data when you're talking about JavaScript and HTML. You're talking about maybe megabytes at most. That's cheap. The delivery itself is also cheap. You throw CloudFront in front of it, it's even cheaper. So kind of keep that in mind. In terms of tips, things to keep in mind, AWS, there's some limits on the number of buckets you can use. So if you're going to build a lot of these websites, you want to try to find ways to reuse individual buckets. You're not going to get more than 100. It's a hard and fast rule. So use CloudFront behaviors to route your traffic to specific paths within a given S3 bucket, and use IAM keys and policies to give access to only the teams that need that. Caching, CloudFront is very configurable and very easy to use, but the performance comes from the caching, so you want to set cache control headers when you're uploading your files. And then finally, secure delivery. CloudFront will let you upload your own custom certificate so that you can have it be, as you're accessing your secure APIs over SSL, you're not doing cross-protocol requests. CloudFront will let you do that while maintaining your brand using the domain that you like to use. So on that note, in my last 30 seconds, thank you for joining us here today. If you're interested in learning more about how Uyala uses AWS and infrastructure as a service, drop by our engineering blog. We're also hiring, and I'd love to chat with you if you're interested in building awesome things in the cloud and helping make better video experiences. So, thank you.